Okay, we're good. You want to start with part 2, I guess. So this one's, I feel like this section was kind of like just knowing how to do it in SPSS again.
Right.
So, part 2. Looks like we're going to need the women poet data file. Okay. Does everybody have that up?
Yeah.
Yeah.
Okay. Okay, so first is, what is the research question? I guess I'll just read this. It says, according to William Butler Yeats, she's the Galaic muse for, she gives an inspiration to those she persecutes? What is that? Okay.
No.
The Galaic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and nonfiction writers. The ages of death for female writers in these categories for North America is given in the data file. You would like to determine if the mean age at death is different from any other categories. So, research question.
Is the mean, if the mean age of death is different in categories of writers? I mean, is that what it's asking?
Yeah, I think so. Yep, if the mean age is different. So B is state the null and alternative. So the null in these ones are always all means are equal, and the alternative is that one or more is different. Okay, 2, collect data. They already collected it by getting the mean age of death. Okay. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert the appropriate well-labeled graph to illustrate the data. I think this is where we're going to use our...
So, and we usually get N, and we get the mean, and we get the standard deviation, right?
Right.
Of all 3.
Uh-huh.
So this, we have to change it now on this yet, or not?
I don't think so, because it looks like they've already automatically recoded it.
Okay.
Oh, they did?
Yeah, because it says novelists are 1, poets are 2, nonfiction is 3.
Oh, that's true.
So put age in the dependent list, factor, and type, and then
Option, you do descriptives, right?
So
yeah, option descriptives and mean plots.
Are we on? Are we doing compare means right now?
Yeah, so you'll go to analyze, and then compare means, and then there's a one-way ANOVA test.
So if we want to get a histogram for this, we do the same. We just go age is the variable and rows is the type.
I think so.
And then we can get the histogram right by each other. Yeah.
Did it work?
Yeah. It says type 1, 2, and 3. So.
Yeah. So did you get 1 N is 67, 2 is N is 32, and 3 is 24? Yeah, so we've got the same graphs. And then you just said you do the same thing for histogram, and it works?
Yeah, you do the same thing for the histogram, and it works.
Okay. Perfect. Inferences. What type of hypothesis test is appropriate? Well, we have to use the ANOVA test, of course. Are the requirements met for this test? Oh, to do that, we have to do the QQ plots.
Did it do a QQ plot when we did? Oh, it didn't.
No, I did a mean plot.
Okay, so we go to descriptives.
Yeah, descriptives.
And then age is the variable?
Yeah. But what do we put in for the... There's no type.
Yeah, it's just age.
Okay, click on age and see what it does.
It gave me one for just one.
Interesting. I don't remember how you do QQ plots for different ones.
You have to go back. Well, we already have a recode on this one.
Yeah, we already have a recode on it. That's the thing.
Well, if we go back and, well, you can't really recode age, can you? That's not what we're trying to do.
Do not use... Okay, let's see. To determine if the data is normally distributed, we use QQ plots. With SPSS, select Analyze Descriptive Statistics Explore, move the variable containing your data into the dependent list, and move the variables that specifies the group into your factor box. We didn't have that.
So data is dependent and factor is... Do you do the variable 3 factor? Let's see if that worked.
Yeah, I tried that.
Well, that just gave me a box.
Well, the thing is that we don't... Okay, so we don't have a dependent list and a factor list. Do you have that on your QQ plot?
No.
I don't have that either.
I just have age, type, and then the...
Variables.
Yeah.
Did you put type into your variable box?
Into my factor one, you mean?
Yeah.
Yeah, well, and I did it both ways.
Oh, okay. What if we put both of them in?
Can you?
Yeah, I put them both in. And it did not help me. It's the same. I don't get this because it says to determine if it's distributed, you'll make QQ plots for each group separately. Oh, I guess we have to do it separately. But how do you do it separately if it's already automatically recoded?
What does it say on the answer? Does it not give us? I guess it just says make them, and it's not a...
It says the data are normally distributed. Note that the requirement is not the sample means are normal, but the data themselves is normal. So the large sample size in groups 1 and 2 do not allow us to assume that the normality assumption is met. This means you do need to do a QQ plot for each group. The QQ plots shown for each group are not perfectly normal, but they're probably close enough to proceed. QQ plots are made in SPSS command Analyze Descriptive Statistics Explore. Move the variable age over to the dependent list box and type into the factor list box.
Age and type. That's what we did, right?
Yeah. Okay, so I don't even have that box when I make a QQ plot. Mine says all I have is variables. That's the only box I have.
On the answer thing, it has box plots instead of QQs on the answer sheet, right?
No, it has QQs. Normal QQ plot of age.
Oh, maybe I'm looking at the wrong one.
Plots tab.
Oh, yeah, it does. Age 1, 2, and 3. I don't know how they did that. I've got for type 1. Oh, I have it. It worked. I don't know how I did it, but I have the QQ plots. Let me think how I got that. That was one of the first things I did, I think, because it's clear at my bottom.
Okay, descriptive statistics, explore.
How do you figure out how you got what you already have on your screen? I don't know how
I'm
to
not
do that.
sure.
Figure out how, but I have the QQ plots.
Descriptive.
You have all 3 of them?
Yeah, I have all 3 of them.
Hmm.
I don't know how I got them, but I do have them. And they're like one of the first things I have on my thing, so I must have got them right out front somehow.
Let me see if I have them.
Yeah, go clear to the very bottom and see if you have them.
No, I don't have them.
Yeah.
I don't know how I got them. See if
Okay, so descriptive statistics, explore, and then type in for your.
Yeah. That's what I did, and then it just gave me box plots.
Explore. Move age over to the dependent.
Did you click on the plots and do the histogram and normality plots with tests? Did you click on that box?
Where's that box at?
Okay, so you go to the descriptive statistics explore, and then you put the age and the type in, and then you go to plots on the side right there.
Age, factorless type, plots. Okay, gotcha.
The plots, and then you go to histogram, and then you go to normality plots with tests, the one right in the middle.
Okay.
Do that.
Okay.
I think that's how I got that. See if that works.
Okay. Yes, I have them now. That worked. That's
Okay.
all I wasn't doing. Okay, perfect.
Okay.
Okay. Okay, compute the test statistic. We already computed it, didn't we?
It should be on there. Well, no. Did we do the ANOVA thing?
Yeah, at the top, at the very first thing we did was ANOVA.
Really? Okay, I'll see.
Yeah, we have the test statistic up there. It should be 6.563. So.
Right. Yeah, we do.
Okay. We've already done this, is what it says. State the degrees of freedom. It looks like 2.
2 and 120.
And 120. So how come we don't choose 122 as well? Oh, that's the total.
Yeah.
We just do the top 2.
Okay. Compute the p-value and compare it to the alpha level.
0.002.
2. And the alpha level for this one was
0.05.
So that is less.
Yeah, so we reject the null
Mm-hmm.
because it's less. Present your conclusion. We have sufficient evidence that the mean age of death writers is different. Take action. Wow. Whatever. Conclude that poets are likely to die early is what it says. Okay. I think we got it. Let's go to the group quiz. Okay, is everybody in the group quiz?
Yep.
Okay, in an ANOVA hypothesis test, we reject H null when there is sufficient evidence to indicate at least one mean is different from others. True.
True.
What requirements need to be checked when performing an ANOVA hypothesis test? They have to be normally distributed, and the variance have to be equal.
Equal. Oh, so B and C.
Oh no, B and C. Yeah. So when it says that they have to be equal, in the lesson it was like, it said something else. It says the largest has to be more than 4 times
Yeah, it
the
says.
smallest.
Yeah, it says they're
Oh, it's
equal.
not.
Yeah, they're equal if the largest is not 4 times the smallest.
Oh, okay, that makes more sense. I was reading it as without that not. Okay, to check if each group is normally distributed, we do the following. QQ plot. 6. We assume the variance in each group is the same if the following happens.
The largest is less than 4 times the smallest.
Yeah, we just talked about that.
Yep.
Okay, an ANOVA hypothesis test is equivalent to conducting 2 independent sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there if there are 4 samples? 4?
You go 1 and 2, 1 and 3. 2. How do you figure that out? Why is that a baffler?
I think it's just 4.
All the different ones.
Yeah, I can write them. You can write them all down.
2, 1 and 3, 1 and 4.
1 and 2. 1 and 3. And then 1 and 4.
2.
Yeah, but we already have 2 and 1, so 2 and 3. 2 and 4. Then 2 and 3 we've already got. Then 3 and 4. I got 6.
6.
I got 6 as
Okay,
well.
I lost the connection for a while. What number are you guys on?
Number 7.
Oh, here's okay. So
Is that all of them? 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4.
Yeah, because we already have a 2 and 3. We already have a 3 and 1. Yeah, I think that's right. 6. Okay.
6. Soccer shoes.
Yeah, the soccer shoes. We need to get soccer shoes. Okay, I got soccer shoes up.
Okay.
This one does not have an automatic recode on it, it looks like. Oh, no, it does. Maybe it does. No, I don't think it does.
Okay.
Okay, analyze. So, transform, automatic recode. Footwear is the one I think we want to transform.
Yep, because that's not in a numeric.
Right. One, 2, 3, 4.
Okay.
5, 6. Okay, I got my automatic recode. Okay, let's go back to the quiz. The soccer shoes has 6 groups. That can be found in the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet, or SPSS.
Okay.
And observe that the p-value is 0.0809. Remove the socks data. What is the p-value?
What in the world is it asking?
Looks like we have to remove socks from it and then see what the p-value is after there's no socks involved.
And we do that?
I have no idea. I don't even remember reading that in the lesson, how to remove.
I've never heard of that. So which one is socks?
Number 5 or 6.
Oh, that's right. Well, so yeah, socks would be 6. So how do you remove 6? That's interesting. Footwear factor.
After you did the automatic recode, you have to type in those groups somewhere, right? Or like, don't you have to do something else? I don't
You
think
might
I
be
did.
able to. Okay, let me see.
The only thing I can think of is just do the analyze descriptives.
You know how there's the options to, like, when you're using your code sometimes you can
Yeah.
tell it like which ones you want to use.
Yeah.
But I don't see it in here.
It's okay. It's not on the analyze descriptives factor list. Can you do options somewhere? Exclude cases list-wise?
Where's that at?
Okay, so you go to analyze and then descriptive, and then you put your kicking accuracy independent, and the factor is a footwear, and then on the side where it says plots and options, on the options, it says exclude cases list-wise. Could that be it?
Yeah, maybe. Let's see if
But then I don't know where you put the exclude cases. On the label? No. No.
Maybe in the recode you can exclude them.
Why did we not learn this? I went over all this stuff. I didn't see this one time.
Yeah, I did too. Okay, maybe we'll just do a Google test.
Box plots now, descriptives, no. Transform. Can you just go and take that number out of the...
Like click and exit them all out?
Well, no, can you just...
Let's see what we can do in the automatic recode. Maybe we can... I don't... Well, okay, maybe... Do you just divide it by a certain number? Do you just divide it by...
Yeah, I'm thinking you just get all the individual ones, you know, when it gives you all the different individual ones.
Yeah, but the only thing is, that wouldn't work because they're t-testing against each other.
So what is the question asking us?
What is the exclude socks? What is the...
When a group is removed, I don't remember that anywhere on the stuff. How do we know how to do that? Are you Googling that?
Yeah, I tried, but I didn't find anything. There's not very much. So the significance was 0.018. Is that what they said? Yeah. Okay. So if we exclude one pair, I don't even know how you would do that. Maybe divide it by 1/6. Yeah, I don't know. I guess we're just gonna have to miss that one.
That is just weird that that's in there when we didn't even talk about that at all.
It says the p-value always goes up when only one group is removed compared to the p-value when all 6 are included. True or false?
I don't know.
And then it says all these questions are when there's a p-value that's removed.
Yeah.
What is the highest p-value you see when removing only one group?
I'm going back to the lesson really quick and seeing if did we miss something like that?
I don't remember it, but I'll go look over the homework because I haven't done the homework just yet. Because I usually do it after we do our group
Right.
review.
Right. I didn't learn that. That's so weird. So we have the, let's see.
Yeah, it doesn't say anything in the homework about this at all either.
All right, well, let's just skip down to 11 right now because it says when all 6 samples are used, what is the maximum variance? We can figure that out.
Yeah.
So the maximum variance we would get by doing the one test. I don't think I've done it yet. We go to analyze, compare means, one-way NOVA, and the dependent list would be the KC.
Yeah.
And so that should give us the statistics. Actually, that's going to be on the descriptive statistics.
Yeah.
That's going to be, we're looking for the variance, and what's the biggest one? The A variance is 27.358. The B variance is 29.484. C is 27.
Wait, are you getting this on the ANOVA test?
Yeah. You
Well,
have
just
to
on the
click descriptives. You have to go into options and click descriptives. So wait, is the variance the 95 confidence lower bound?
No. So 31011. So all the variances on all the individual ones you look at. So A, B, C, D, E, and F. And F one is 40.724. Do you see where the variances are?
I don't see the variances.
It's just by standard deviation. It's in the. It's down right by standard deviation.
I've got a group of statistics, and I have A, B, C, D, E, SOX total, and then I have N mean standard deviation error.
Are you okay? Are you on? Yeah, you're on the descriptives, right?
Yeah.
So just go down, like there's mean, median, variance right there. Do you see like it's like the fourth one down, fifth one down, 1, 2, 3, 4, fifth. It says variance.
I don't see that for some reason.
It's right above standard deviation.
Okay, I have standard deviation.
You don't have variance right above standard deviation?
No, we have a horizontal. Like box of information.
Yeah.
Well, then just go to Analyze Descriptive Statistics and Explore and just get those descriptives up.
Okay. So is that what you did to get that?
Yeah.
Oh, okay. We just did it through the ANOVA test.
Yeah, I did the descriptives first.
So
for
the Explore stuff,
Analyze, Descriptive, Explore, and then you put in
code footwear.
Yeah, kicking accuracy and footwear, and then probably options or plots you could put in your other stuff.
Wait, but what's the dependent list?
Dependent is kicking accuracy.
Yeah.
And
factor is footwear.
just the code one?
Yeah.
Okay, I've got my variances now.
So yeah, now it's asking us
What's
with
the
all the
lowest?
6, which is the smallest, and it looks like to me it would be 27C.
Yeah, 27.208.
And then the largest would be the 53.158. Are you guys getting that?
53.158.
Yeah.
Yeah, that's what I got. Yep.
And so to test the equivariance, then you got the largest and the smallest,
So it's got to be
and it says
largest is not
largest
more than
variance
4
divided by the
times.
smallest, less than 4. So
It's way less than 4.
divided by smallest, right?
Yeah.
53.158 divided by 27.208 equals, and it has to be less than 4.
And it is.
And it is, so they are satisfied.
Okay, construct the QQ plots for these.
And we should have those if we push that button on normal, but I don't know if I push them. I have to do. Oh, I have them.
Okay, I've got them up too. Let's see.
Maybe I have my wrong ones on. We're doing soccer shoes, right?
Yeah, we're doing the QQ plots.
Yeah, it looks like the one on B is a little weird, but pretty close.
They're pretty close, yeah.
I would say yes.
Yes. The test statistic for ANOVA is an F statistic. Is the p-value the area to the right or to the left?
Right.
Right. It's right skewed.
Yes, always right skewed. Okay, now back to the other really weird questions. What? P-value.
How to exclude a group.
Is there any way to just go back to the original data and just delete that part?
I don't know.
Probably, I mean, you could. You probably could just delete it. Let's see.
Can we just do it by hand?
I don't think we can, but I'm not sure how we.
Well, how you get them is variation. It's that one ANOVA test. It has all the information.
Are we doing a one-way ANOVA test or a two-way?
One way?
One way?
Yeah.
Okay, let's see.
So the stuff that gives us information is on the ANOVA test. I'm trying to find where that is on my thing. Do it again. Picking. So what would go down is the what is that called? The DF.
Degrees of freedom.
Degrees of freedom would go down because there would be less groups, and the mean would go down. So if both of those go down, would the significance go up or down? You see what I'm saying? Because those would lose both of those things. So if we had like 60. I just don't understand. Dang it.
I'm trying to search it somehow to figure it out.
Okay, so let's think of this logically. If you have less things to compare, would the number go up or down? If you're dividing a smaller number.
It would go up.
It would go up. That would make sense.
Mm-hmm.
So that should be true. What is the highest p-value you see when removing only one group? They want us to come up with numbers. There's got to be some way that we can do this on there.
Yeah.
Everything on Google says that you're supposed to do a one-way ANOVA test, but I don't. Oh yeah, we were doing a one-way.
Yeah. Remove the socks data. Can we just go on there and delete the socks off of our thing?
Yeah, I think that's what we should just try and do and see what happens.
So how do we do that?
I'm just
highlight it all and delete it.
Yeah. Okay, so then once we do that, do we get a different transform automatic recode thing?
Yeah, I would recode it again.
So we're recoding footwear.
But where is it that you're highlighting? Like, what did you highlight?
Just to go down to the very bottom of the original data you get and just highlight all the socks data.
And just delete it.
And then delete it.
It kind of seems dumb, though. That's how you have to do it.
Yeah. So then I just changed my recode to something different so I'd know it was different than the footwear recode. I just put foot 2. And so then we go to analyze, and we're trying to get, so probably the compare means one, and the one way.
Yeah, one way.
And then we just go to the one we just did.
Options.
Now we go to kicking, and then we go to the one we just did as a factor.
Okay, so in this case, I got the significance was 0.309. So the significance is, that went up.
So that was right that it went up. And so now what is it asking us next? We should have the stuff we need now. Oh! Okay. What is the p-value now? Is that what it says? 309? 0.309?
That was 8. Yeah. What is the p-value? 0.309. When removed, all 6 samples are included. Okay. What is the highest p-value you see when removing only one group? You will need to compute an ANOVA for each possible option. Oh, that sucks. Because we have to remove each one somehow.
The same way we did before, but how do you do it without... Can we each take one?
And you can't undo it. It won't let me undo it, what we just removed.
So that sucks. What's the highest p-value when you see when removing only one group? Okay, so that would make sense if... Would it be the highest group in the first place?
Yeah, whichever group has the highest
mean, or
yeah.
So we can just go to that one we just did, and the highest group would be the A. Is that right?
Yeah.
Would it be the highest standard deviation, or the highest mean, or the highest variance? I mean, I don't
know. I don't even know how to do this.
I mean, we are just winging it because we did not learn this. So.
Okay, well, I think we just submit it or either save it for later and then email our professor.
There's a high value.
For 9, it's true, right? 9 is true.
Yeah.
9 is true. And I think the 8 is 0.309. I think that's right.
Yeah.
but 10, which is the highest p-value you see when moving one group.
I'm gonna send him an email real quick.
Because I don't. How are we gonna know that?
So we're just skipping that one.
Yeah.
All right. Did you submit it?
Should we just save it for later and?
Yeah, that's what I
he
did.
says?
Yeah.
Save it for later.
And then we'll submit it when he. Does he email you back when you email him?
He occasionally does.
Oh. All right.
Mostly he does. But usually you figure it out before I get an email from him.
Okay. Well, I'll work on it and I'll let you know if I can figure it out.
Okay.
Oh wait, it says you must submit your answers to complete this activity. Saving does not submit. Now you just put OK, right?
Yeah. Yeah, because we're just sitting. Yeah.
And we can just put done now, and we can come back to this, right?
Yeah. Yeah.
Okay. Yeah, I'll see if I can figure it out, but hopefully.
Okay.
Okay.
I'll email him and let you guys know too.
Okay, sounds good.
Yep. See ya.
Thanks. Bye.